right. Good morning, good afternoon, good evening, depending on where you're joining us from. My name is Daniela Ngarambe, and I'll be your moderator of the day. We are very excited to have you join us for this important webinar. And just to give you a rundown of what we'll be doing during this 1 hour and a half, um, we'll start with welcoming remarks from Engineer Nutifafa, who's the head of training at the African School of Regulation. Then I'll do a small introduction of who our panelists are, and then we'll jump straight into the questions. Please feel free to ask your questions via the chat, but also to raise your hand during the Q&A session of this call. And after that, we'll have closing remarks by Debbie Rhodes from AFUR, who is also our co-organizers of this important webinar. So as we start, I'd like to welcome Engineer Ntifafa for the welcoming remarks.
Thank you, Daniela. Thank you. Daniela, please, can you hear me?
Yes, we hear you fine.
Okay. Okay, good morning, good afternoon, everyone, depending on where you are joining from, distinguished panelists, participants, and colleagues. On behalf of the African School of Regulation, I would like to welcome everyone to this webinar, very important webinar, of course, on data systems and technology for utility regulators in Africa. And we are very pleased to collaborate with AFUR again on this very important topic. As we all know, effective regulation depends on reliable data, strong digital systems, and the ability to use technology to support sound decisions, monitor utility performance, protect consumers, and improve sector outcomes. So we cannot have effective regulation without data. Data is very key. So today's section provides an opportunity to share experiences, learn from one another, and reflect on how African regulators can strengthen their data systems for more transparent, responsive, and evidence-based regulation. Thank you to AFUR, our speakers, and all participants for joining us. I wish us all a productive and engaging discussion this afternoon. You are all warmly welcome. And I look forward to a very fruitful discussion. Thank you all. Thank you, Daniela. I hand over back the floor to you.
Thank you very much, Nutifafa. Well, before we start, I'd like to introduce our panelists. I'll start with Engineer Jim Green. Engineer Jim Green's career spans more than 40 years with extensive experience across a number of industry sectors, including telecoms, aerospace, internet, information technologies, and critical infrastructure. And this experience includes leading the development and global deployment of the world first MPEG-2 DVB digital pay TV platform known as DSTV Africa. I think a lot of us are familiar with it. And the development and deployment of first digital multi-channel satellite TV signal distribution platform for cable TV in Europe, and a major interdepartmental government program to integrate information systems to modernize South Africa's criminal justice. Welcome, Engineer Jim Green.
Thank you.
Thank you too. And on the call, we also have Professor Aswar Hamajinda Hilonga. Professor Aswar is the Executive Secretary of the Energy Regulators Association of East Africa, also known as AREA, an internationally recognized innovator, entrepreneur, and researcher. And he's best known for pioneering the award-winning nanofilter water purification technology and for advancing practical solutions in water, energy, environmental sustainability, and innovation-driven development. He's currently spearheading AI, enhanced training, and digital transformation initiatives through the ERCE, also known as the Energy Regulation Center of Excellence, which is known for promoting the use of AI, data system, and emerging technologies to strengthen utility regulation, improve evidence-based decision-making and enhance service delivery across Africa. And his work focuses on bridging innovation, technology, and regulation to support sustainable development and regional integration. We're really happy to have him today. And he's currently a FOR's cybersecurity coordinator to develop cyber resilience programs for regulators of critical infrastructure across Africa, and is an ASR alumnus as well. So we're very, very happy and excited to welcome Ms. Professor Aspor on the call. Welcome.
Thank you. Thank you so much. And greetings from Tanzania.
Greeting from Tanzania. We also have Dr. Frederick Otieno on the call. Apologies, I'm having issues with my laptop. But then we are excited to welcome Dr. Frederick on the call as well, who I'll introduce a bit later as we start the webinar. I'd like to start with a question for Engineer Jim, as well as Professor Aspor, to kickstart the webinar. And my first question is around data and quality. And the first question is, how should regulators get reliable data for decision making, considering our context in Africa as well? How should regulators get reliable data? So the question goes to Engineer Jim Green, as well as Professor Aspor, as we begin.
Well, I think the starting point for this is what we call doing the data definition. Certainly in my experience in government, where we had to get different systems to talk to each other, the local understanding of what data represents differed quite greatly, even though they used the same, call it labels, to explain what the data meant. So we had to sort out this whole issue of what we call semantic equivalence, and in a sense create a common language in terms of what was expected. The next thing that data quality for me was how is the data derived is a question we have to ask ourselves. So, you know, a lot of regulators are relying on Excel spreadsheets and forms, which means between, call it a system producing data and you consuming the data is some human intervention. And we all know what the problem with dyslexic fingers are. These are all issues that may render the data unusable or at least reduce the quality of the data. So how the data is generated is actually a fundamental question. So if for instance, we wanting to understand, let's say, some quality of service measures, if the indicators that we are monitoring are instrumented from live systems using agreed standards, then the data will be much more reliable than, in a sense, picture somebody going into a power station with a clipboard, taking down readings, noting power outputs, et cetera, maybe from time to time, and then submitting that, and then both the creation of the data that you're going to use as a regulator has been, in a sense, hand-built. And then as a regulator, you now have to, in a sense, copy this into some system or tool that you're going to evaluate the data with. So the more that you have human involvement in the creation and the consuming of the data, the more you have risk to the quality of the data. So looking at a seamless process in terms of how is the data created, where is it created, under what conditions, what does it represent, are key underlying questions to establishing the data quality thing. And then you want to basically preserve the integrity of that data when it's transported to the system that's going to be used to, in a sense, analyze the data or to respond to it in any appropriate way. So for me, data sharing starts with, in a sense, a data sharing agreement, where these fundamental business issues have to be worked out and then translated into the technology of the party that's producing the data and a regulator, for instance, as a recipient of the data in terms of how we actually going to process and use that. So, I mean, maybe that's a bit of a starting point for that. Perhaps Dr. Frederick, you might want to add or bring a different view.
Please go ahead, Dr. Frederick. But before you do, I'd like to introduce you as well. Dr. Frederick Otieno is currently serving as the Deputy Director, Consumer Protection at the Energy and Petroleum Regulatory Authority, also known as EPRA. in Kenya, and he is charged with safeguarding energy consumers by addressing complaints and disputes, enforcing service standards, promoting fair pricing, enhancing consumer awareness, and ensuring compliance by energy providers, and protecting consumer rights across Kenya's energy sector. Dr. Frederick is a DAD alumnus, having benefited from the prestigious German academic exchange service, the DAD scholarship offered by the German federal government. He's also a registered member of the Professional Criminologists Associations of Kenya, the PCAK, and a certified security management professional. And Dr. Otieno holds a Doctor of Philosophy degrees in Peace and Conflict Studies from Masinde Muliro University of Science and Technology and Political Science from the University of Dar es Salaam. And in addition to that, he holds a Master's of Arts in Security Management and a Bachelor of Education from Edgerton University. And prior to that, Dr. Tierno served as a high school teacher at Namuboto Secondary School and later joined the Kenya Police Services, where he received specialized training in Kenya and Israel. And he has also worked with the county government of Saya, Maseno University, Africa Nazarena University, and the University of Nairobi as an adjunct lecturer. And Dr. Otieno is also a widely published African researcher specializing in forensics, consumer protection, security, peace, and diplomacy. So you can see that we have a panel of experts. So please feel free again to ask your questions. And we have a very well-informed panel. So again, this is an invitation for you to ask your questions in the Q&A and also raise your hand. But Dr. Frederick, if you would like to provide an addition to the first question, you're welcome. You're muted, Dr. Tim.
Okay, I think I've unmuted. Can you hear me? Daniela, can you hear me?
Yes, we can hear you, yes.
Yes, yeah. On the issue of reliable data for decision making, I work with IPRA, Energy and Petroleum Regulatory Authority in Kenya. And in Kenya, we do a lot of licensing utilities. So when you are licensing utilities and even individuals, we get a lot of information. We get a lot of their information about their data, which we store in our system. So for me, getting reliable data for decision making should not be a one-off thing. So because data, you should depend on multiple sources. So as utility, as EPRA, we normally do what we call standardized format for getting data from utilities and from individuals. Those who apply for licenses, we go through their data, and this data also include personal informations, which are very much confidential. So this data we keep, and we also triangulate, because some of these licensees, some of these individuals can actually give false information. So we also verify this information with relevant agencies. For instance, the identification card number, the Kenya Revenue Authority, the taxman compliance certificate. This particular data also we go and verify with the taxman so that we can get reliable information. So this data also we get in forms of services that are provided. For instance, we have got smart meters that consumers use. So these smart meters use a system known as IoT, Internet of Things. And we are able to get real-time data about consumptions and about individuals' households, consumption level, and their information. And therefore, whatever we do with this information is that we synthesize it, and then we take the necessary data that we need for a particular assignment. So when we are doing this, I will ask other regulators, because I'm in the energy and petroleum space, and we also have got transport sector. We have got a water sector here. So for you to get reliable information, you should be able to triangulate the information that you have. You must do verification for the data that you have for it to be authentic. So you can use multiple sources. We have got even reports from various utilities and even from various players in the market. So these are kind of data, these are kind of materials that you also use to verify and make data to be authentic, so that by the time we use data, we consume that data, we actually confirm that the data is actually true, is verifiable, and is accurate. So that is what I will actually urge most of the regulators to ensure that most data must be confirmed, must be verified, and must be triangulated. Thank you.
Sorry to take you back, but what do you mean by triangulation? I don't know if
Okay.
you've mentioned it. Yes, just
Yes,
like take us to what you mean by
triangulation is a
triangulation.
research term. You have used it in research, in my research. To triangulate is to try to verify data with other sources. That is triangulation. Verification with other sources
Okay.
to
Thank you
confirm
very
accuracy.
much.
Yes.
And
Yeah.
you talked about standardization. So what's the best way to standardize the data you collect?
Yes, so to standardize, before you collect data, as a
Mhm.
regulator, EPRA in Kenya, we regulate, I've said we regulate energy and petroleum sector. So for us, we normally have got a standard format
Okay.
that is used by all people who are applying for license, for our licensees, and even individuals. So we have got a pre-formatted form that every individual use so that we don't get a mosaic of information that some are unnecessary, so that we are able now to just map this particular data. We can map this particular data and get the correct information. We can actually use artificial intelligence to map this data by the click of a button. So that's the way in which standardization happens. You must be able to come up with a prescribed format that must be used by everybody. So, instance, if you are using for instance, in energy and electricity generation, if you are using megawatt, you can choose to use megawatt hour or kilowatt hour. So if you don't standardize, you will get some information on kilowatts and in megawatts. The same, some people will give information in terms of centimeters, and some in terms of meters, some in terms of inches. So you standardized, you get the one metric that you use throughout in collection of data. If you are using centimeters, you allow it to be centimeters and not meters. So that is how the process of standardization.
That works. Okay, that's very helpful. Thank you very much, Dr. Etienne. Professor Asquar, would you want to add a bit of details to the question on data and quality?
The explanation that Jim has given, and Dr. Otieno, who also studied in Tanzania, I'm so glad he was there, and at Masinde Muliro University, I hope you know Professor Makanu there.
So, yes, a good friend of mine.
Yeah, Makanu is also my good friend. So, Dr. Otieno, thank you very much for this very comprehensive description on what EPRA does. By the way, EPRA is one of the member of AREA. So we have other 10 members. So together they are 10. So our work now is to harmonize whatever they are doing now. That he just gave a perspective of EPRA. Now there are EPRAs of other countries. In Uganda is ERA, in Tanzania EURA, in Zanzibar ZURA, and others. Now our work is to coordinate, to harmonize them, like how they collect that data, then to look now at the big picture in East Africa, and because these days we are talking of cross-border energy business and so on. So it's important now what EPRA does in relation to EURA, because later when we connect that Mwalimu Nyerere hydropower to Kenya and to Zambia and to others, we see this cross-border business. So the previous data now can be easily extrapolated to predict the future consumption and so on. So that is now what we are doing at ERSE, Energy Regulation Center of Excellence. We train these regulators, we bring them together, we build their capacity on AI, use of AI. You know, this data we are talking about here, it looks simple. When you collect a one-day data, is simple. Okay, how much electricity was consumed, let's say, by factories, by household, by it's simple, like one day. Okay, add the second day, add third day, add 1 year, add 10 years. Wow. Now it becomes big data, and that's only for Kenya. Now, if you look all these countries, it's headache. Now, as he said, by click of a button, using AI, you can easily process this information. So we are training them now to build their capacity on using this. So they should not feel that data is overwhelming, like, oh, this is too much. No, it's not too much. Just give us that raw data and we will help to process. Now, the challenges we are getting now is on the issues of confidentiality, like protection and what. Those are the things sometimes we inform them, like to use a dumb names. Just don't mention like because they are very sensitive, like this systemic data for petrol, for this gas production, and they are very sensitive with this data. So we say, okay, just give a dumb name A, B, C, D without mentioning those plot numbers and so on, so on. But the issue is how can we simplify this data to interpret the information and to utilize it for the future business trade or energy trade and so on, so on. So that's our direction as area. Our work is to coordinate Otieno and the other Otienos of East Africa. Thank you very much.
Thank you very much, Professor Asquar. I think you touched a bit on the question, the second question I wanted to ask around balancing open data with security. You get a lot of data, but then we even have a question in the chat around. I hope during the verification process, the personal data protection policy is put in consideration. So my question is, how do we balance open data with security? So the question goes to all of you, and I'll start with Jim Green, and then we'll go to Dr. Frederick.
Okay. Well, I think the starting point for me is that whatever we do as regulators can't, in a sense, bypass the local legislation in terms of privacy. And if we just look at the privacy issues around that, just picking up on what the good professor basically mentioned earlier, is most privacy regimes require a purpose specification for the use of the data. And that limits the extent to which you can use the data within the terms of privacy legislation. And privacy itself is actually fundamentally a security issue. When we look at information security, we're really looking at three aspects to it. We're looking at how do we maintain confidentiality, which really is defined as basically ensuring that only authorized people can actually view or work with the data. We've got integrity, and that is we need to make sure there's nothing in the system or an unauthorized person can alter the data in some way. And then, of course, the whole issue is availability in terms of how much tolerance can we have? How do we need that data available real time? And that's largely driven by what the data is being used for. So if it's feeding into real-time decision making, then you need a high availability system for it. Now, if you apply those practices, we've got three areas we have to apply that to from a security perspective. One is the data, what we call the data at rest. So if the data is sitting in a database and it's not being used, we still have confidentiality, availability, and integrity issues to be concerned about. The second issue is the data in motion, and that's typically when you communicate the data, could be across the internet or some other medium, to the intended recipient. How can you ensure that the integrity of the channel that it's being communicated on is maintained? Because again, there you have a confidentiality, integrity, and availability issue. And then the third step from a security perspective is how can I process the information in a way that preserves its integrity, availability, and confidentiality? Because now I might have people or machines or processes working. And when we add the dimension of artificial intelligence in through the lens of privacy, and if we look at European legislation, for instance, now all of a sudden, where you're processing personal information using AI, you've got the big issue there of explainability, because privacy law, and this is being adopted in many jurisdictions, the decisions made must be explainable. Now, if we think of artificial intelligence, for most people, it's in a sense, call it the proverbial black box. You put information into it. We're not exactly sure how it comes to what it does, but it produces an output. So that puts a real challenge on what did the black box do from an explainability perspective. So, because AI is a very broad catch-all term that covers many different algorithms and even combinations of algorithms. So the change in mindset from traditional programming to artificial intelligence is in previous years where we wrote normal programs, the specification for the program said, you get this input, this is what you must do with it, call it the algorithm, and this is what you must produce output. So the explainability was very simple. We could explain the algorithm, we add these together, we make this decision, we get this result. With AI, this program runs in a sense on its own, and you put data in, you tell it in the training information, if I put this data in, this is my expected output. And then the program works out its own associations to say, how did it get from that source information to the desired output? So that's the training phase. And then the use phase is then you put the information in and you hope that it applies the algorithm that it developed to produce the output. So that's quite a fundamental mind shift, particularly when it comes to privacy and security and the whole question now of having to answer to a data subject. How did we actually arrive at the decision that we made, for instance, to terminate your service or to revoke your credit score or demand a higher deposit for you for a service because you're considered an at-risk customer? These are all things that then fall into this category of explainability. So there's quite a lot of challenge around that side of things, but the fundamentals of information security actually still apply. Now, I don't see really much of an issue between, call it, data openness and sharing and security. So if we took the data at rest example, let's say you're creating a public website that you're communicating information to any user in the community or whoever's interested, public information. There's still a security dimension to that, although the user can still do it. You still need to protect the information that's behind the site against tampering, fake news, and all the other things that could happen if somebody could manipulate the site. So data openness and security are not necessarily mutually exclusive terms. Security still applies no matter how the data is being used, whether it's to a limited audience or to call it a very classified, highly sensitive area. The principles actually still apply, except now what you're doing is you're basically dealing with the question of confidentiality. Who's included within the group that we would consider the confidentiality dimension is restricting to in terms of who would be the authorized user base for that information. But from information security practice, those principles still apply regardless of who the target audience is. So I hope that's kind of given a little bit of perspective on the two. They're not mutually opposing concepts. Yes.
In summary, open data and security are not mutually exclusive. Thank you very much, Engineer Jim Green. We have some questions in the chat, and before I continue with my questions, perhaps I'll take one or two. I'll start with the last one. Emmanuel is asking, good afternoon, everyone. The concept of information asymmetry is common in regulation, which explains the fact that the regulated entities have more information than the regulator. His first question is, how does the regulator ensure that the regulated entities do not use this to their advantage? And the second question is, what tools or systems can the regulator put in place to curtail this and ensure that information or data flows consistently from the regulated entities to the regulator in a timely and consistent manner? So I'll ask the first question to Dr. Otieno. How does the regulator ensure that the regulated entities do not use information asymmetry to their advantage? Yeah.
Yes, for this is, you should be able to put in controls at various levels so that there's an information that is available to individual depending on the need to know and the need to use. Again, there's a framework. You should come up with the regulations that govern the use, handling, processing of information and data, personal data. And in Kenya, I'm very happy that we have got what we call the Data Protection Act 2019 that actually governs the way data should be used, should be stored, and should be processed. So the thing here is that you must have controls in place that safeguards the use of a data. And then the Data Protection Act provides for various levels of categorization, how data are categorized. So we have got restricted data, we have got public data, and then we have got also confidential data. So as an individual, as a regulator, or as an entity being regulated, you should be able to categorize data and know the level of data that you need to give out. And also for your employees, you should be able to give them various levels of access to information, so that if the information leaks, you actually know at what level did the information leak. For instance, in my organization, I'm the head of department, I deal with consumer protection. And in consumer protection, as the head of consumer protection, I get a lot of complaints from consumers, from people complaining about bills, about services, about whale leaves, about petroleum. And these people normally give us a lot of information. Some are very sensitive. They give us their own details, the details of their neighbors, the detail of the perpetrators. So it is upon myself now to know which other information do I need when I'm now giving this particular information, the complaints or the disputes to my officers when I'm assigning them, or when I'm making the system, when I'm designing the system. Because for us in IPRA, we have got a system that actually when you have got a complaint, some people come through walk-in, some are sent via phone call, some are through emails, some are through portals and the systems. So I have a system that is able to actually analyze thousands of complaints and disputes and then assign them individuals, officers. So these systems, I've designed this system in such a way that there are some information that does not trickle down to the officers, to the manager. And then from the manager, there are certain information that also do not trickle down to senior officers. And then it also goes down to there are some information that are now accessible to officers. So at my level, I can actually access so much information. And now from there, I'm able to filter as the information goes down. So those are kind of controls that should be able to be adopted by various utilities, entities, and even as a regulator. And just going back to what Jim Green was talking about, a regulator worth his salt should be able to strike a balance between transparency and protecting personal data. And I indicated, like in IPRA, for instance, we have categorized data that we receive because we receive a lot of information from our licensees, even from the consumers, from the complainants, from the customers that we come across. So we normally categorize data. So we have got the public data. These are just regular data. For instance, the tariffs. We normally publish tariffs every month, electricity tariffs every month. This is a public data. We have got a energy report, which we also publish annually. This one is available in our website. It is categorized under public data. We also have got regular reports that are normally submitted by some of our licensees. These ones are public information, and therefore we treat them as public data. Then we have got restricted information, restricted data. So these are data that contain sensitive information. For instance, trade secrets of OMCs, oil marketing companies. Their trade secrets we don't give out. But you see, these OMCs also provide us with the data about their consumption. How much petroleum do they receive? How much do they give out? So that actually we are able now to monitor stock level. So these are information that we can give to the public. But the issues to do with the trade secrets, these are now treated as restricted data, and therefore we don't give it out. Then you also have got confidential consumer information, personal information. Though confidential information are personal information about various consumers, about their name, their location, the number of persons they have in their households, because these are data that we actually need even when customers are being connected. So these data are confidential, and we don't allow release, or we don't allow the entities and even licensees to reveal this data at any given point. And of course, we have got mechanisms. We have put mechanisms in place and controls in place, and also regulations in place that also stipulate the offenses. We have got offenses. We have got penalties and sanctions for those who violate these particular data protocols and the Data Protection Act. In conclusion, I can just say that open data is very much important. It promotes public trust. It also promotes investor confidence. So data is a key thing because it is the thing that will be used by people, by licensees, by investors to make decisions on whether to invest or not, on what to do, to project, and even to know whether to invest or not. So data must be treated with utmost discipline and utmost level that deserves. Thank you.
Thank you very much, Dr. Frederick. I'd also like to open to have Professor Asquar, to give the opportunity to Professor Asquar to also answer this question around information asymmetry and what tools or systems the regulator can put in place to curtail the issues with involving information asymmetry and ensure that the information is consistently flows from the regulated entities to the regulator in a timely and consistent manner. The Professor asked for. I see we have a lot of questions in the chat, so I'll try
Yeah.
and address them. Yeah.
Yes, maybe briefly I can just respond to this that it's not that much easy. But I like also one approach that EPRA is using now. I was attending one of their conferences in Nairobi a few months ago. They use the approach of research. You see, you can reveal very critical information, but through research, research has got its own ethics. How did you get this information? Because it is generalized to just get the overall perspective or trend of that particular issue of concern instead of name tagging and specifying the particular entities or individuals. So you do it in terms of a research. I like what EPRA is doing. Maybe Otieno later will respond. So that's one of the approach. But again, we are developing now a database. Like this information that is saying it's public or it is should could be available online but in one spot center where we can have a database. I see in Burkina Faso, someone is also put in a comment there that they are developing this kind of a system. Can I just go in one data hub where I get all the informations of all these regulators in East Africa? So anyway, whenever you think of me, think in terms of all entities of regulators in East Africa. So with that pattern, we can even extrapolate that if these cases are happening in Kenya, most likely it is the same case maybe in other countries of East Africa. So we can use that generalization finally to attract the investors in our regional bloc because the patterns are almost similar. But again, that's what I said. EPRA is already leading on this. And so we are encouraging our other regulators also to borrow a leaf and to learn from these leading organizations like EPRA.
Yeah. But perhaps I can just put an extra comment on the question, Daniela. I think in terms of information asymmetry, I like to look at two main areas. One is if we think of what is the regulator's primary role? Well, obviously the one primary role is managing cost of service, which ultimately will translate into tariffs for the user. And the other one is quality monitoring, so quality of service. So they almost, in a sense, two different dimensions of the same coin. One is the requirement that the utility will, in terms of, so for instance, claiming its costs and its capital required, etc., and they will work on a certain model which is informed by whatever cost base they have. And of course, in terms of the asymmetry question, what other costs they would like to, in a sense, bury in their declaration of cost, which may not be a cost. And that could even be a political thing. So, for instance, some utilities, I've seen in some places, there's a political dimension to what they're doing, saying, well, you also need to help answer our unemployment problem. So as a result, what happens is their costs that they add go beyond the costs of delivering the essential service, because they're in a sense not only now being a utility, they're also in a sense being a training organization to help deal with the, call it the social agenda, social political agenda of now employing additional people. So that would skew the whole claim in terms of what cost the end user should pay for, let's say if it was electricity or something in that perspective. And the only way that I can really think there comes down to the whole issue of benchmarking. So I think as we share amongst ourselves, or as regulators, develop a way which probably will be sector specific, say for instance electricity, and we build models for what it typically costs, and we can compare that to worldwide costs. We can start to identify things like, are there inflated capital costs? Let's say we're putting up a solar generation project. We should be able to, in a sense, make fairly informed decisions as to what the project cost would be typically that the utility would like to recover over its payback period. And we should be able to say, well, is the demand that they're making excessive, or is it reasonable within that term? And a lot of this information is actually more broadly available, even publicly in other sectors. We could take into consideration local issues like transportation costs and connectivity and various other things that might be required. But that would all go into the call it establishing the cost of service. The second area then, of course, is the quality of service. Now, I think one area that I haven't seen utilized much, but it's as Dr. Frederick mentioned, is the whole issue of Internet of Things, or IoT. There are lots of, call it, low-cost sensors available, and for regulators to, in a sense, have access or create what we call a sensor network, they could monitor things. If I take electricity again as an example, what percentage of brownouts are we having? How many power losses, fluctuations are we having? Is it within the service level agreement requirements? Is the harmonic content excessive? Is the reactive power incorrect? Now, utilities, in a sense, do monitor that from the perspective of having to maintain their network, because certain parameters, if they get outside the bounds, operational bounds or limits, will need to trigger automatic shutdowns or whatever the case may be. But if you're now sitting on as a regulator and you're receiving lots of customer complaints that the quality of electricity in a certain area is bad, and you can correlate that to any sensors you've got in that area, then you help remove some of the subjectivity out of the customer complaint, because they might be able to tell you, I can't understand why my appliances keep failing. But your sensor network might tell you, well, we have over voltage problems. So the user's not seeing that the voltage was too high, which was causing, their motor to burn out or whatever the case may be. They just register that as a complaint. I plugged this into my socket. The electricity blew this thing, and it's happened now 3 times now. That would be a typical complaint you get from a consumer. But with access to some sensor networks down at the distribution layer, et cetera, would be helpful. Now, obviously, when we take the picture up a level into transmission, and we're thinking now particularly cross-border wheeling of electricity, et cetera, maybe I shouldn't use that term. Again, the whole issue at the system operator level now is matching supply and demand. So where's the supply coming from? Where's the demand? What's the seasonality? That would be another whole dimension to this thing, where I think regulators would be well placed in terms of AI and some additional modeling, again, probably from things like sensor networks as well. So I hope that answers it. But I think at the end of the day, to deal with information asymmetry, you need some standards to compare it against, to see whether the tolerances are reasonable. And then the monitoring of service, how much are you getting raw data that you are processing versus how much are you reliant on the utility to actually provide that information in an objective, call it unadjusted fashion, if I can put it that way.
Thank you very much, Jim. I'll read the questions in the chat because they're quite a lot, and I would want all the questions to be answered in this session. I'll go to the question around Malawi's question. And she or he says, through experience, how have you handled silos within the regulatory institutions? We have a challenge of having conflicting information or data per department. For example, licensing will have a certain number of licensed institutions or entities, and another department will have different statistics. So how do you handle silos within regulatory institutions? I think Professor Askor keeps referencing EPRA as a center of excellence, or as an institution that does really well. So I'd like to ask the question to Dr. Frederick, and also if you can get a perspective from a regional perspective from Professor Askor, that would be really well as well. So Dr. Frederick.
Yes, thank you very much. For us, we do what we call harmonization of information. And we have got a platform where all informations are shared, an intranet where all informations, including sensitive informations, are shared. So, and we don't actually work in silos. In EPRA, we have got representative from all the departments. For instance, in licensing electricity, we have representative from all the departments in the organization. Matters licensing of petroleum products, we also have got representative from all the departments in the organization. And these informations are available in our intranet. And that is why even when our enforcement officers goes out, because they don't do licensing, yes, they have got a representative there, but then we have got a way in which you can confirm the information. For instance, we have got scanners that you can use to scan information and get whether the license is authentic or not. And you see, this one also is available to the common man out there. So that even an individual, when you are going to buy petrol, when you are going to buy fuel from a fuel station, and if you want to know whether that fuel station is licensed or not, you simply ask them for their license. Then you are able to scan the barcode, and then you get the information. Even for our officers who goes out in the field, we have got our personal identification numbers, because anybody can go out there and then pass as an EPRA officer. So when you are doing enforcement, you are doing inspections, you simply give out your badge, which contains your ID number. And then from there, we have got a short code system which is used, available to common mwananchi. They use this one to verify whether you are a bona fide employee or not. So for us, EPRA, we don't work in silos. We have got data harmonizations, and then there's also interdepartmental linkages. And we have got a platform whereby you see all that is happening in the organization, the licensing procedure, everything that goes, even importation procedure, procurement procedures, processes within the organization, so that anybody can answer any question. You don't have to be a petroleum officer to answer any question about petroleum, because even the number of stock, the minimum operating stocks, the import every year, the tariffs are available for every individual, and you can actually query. So the issue here is to have what interdepartmental cooperation within the departments within an organization.
And therefore, whatever he has mentioned here now, the work of area is to harmonize those activities. So we have 2 meetings per year, every year, at the where we invite the what we call portfolio committees. Those are the experts of each regulator in different fields. For example, for electricity and renewable, there is an expert, representative experts from every regulator. So they meet twice a year and they harmonize all the activities they do. They write a joint report, and those reports are available for whoever needs it. And area is the custodian of the reports. And then there is a legal portfolio committee, there is a petroleum portfolio committee. And so those committees, they meet, and this is where they share their practices in each country, in each regulator, and that's where harmonization comes. So it's a very standardized process. But again, I don't say everything is flowery, and there are challenges here and there, but we have a regular system, a standardized way of doing these activities.
Yeah.
Thank you.
Thank you very much, Professor Asquar.
Yeah,
I'll
but
read.
perhaps
So go ahead, Jim.
yeah, just that in a sense, what Dr. Friedrich and Professor Asquar have basically spoken to is, in a sense, what I call the macro issue in terms of this and now it's cross-party data sharing. But to effectively participate in a cross-data thing, your own house has to be in order. And maybe just a comment there, organizations that have been using technology for a long time typically have emerged with what I call the point solution problem. So when IT was first adopted, some department within, say, for instance, a regulator decided, well, we can use technology to fix this problem. And
You
then we
need
had
to tell
another
us
one.
what IT is as well for our
Information
audience.
technology. Sorry, or I try not to. And what happens is within the very organization you're in, you'll find what we call many versions of the truth. We'll have different data sets that all refer to the same thing, but have different perspectives on it or treat the subject differently. So we turn that an organization that has that problem has what's known as a master data problem. And to deal with that, it has to actually take some hard decisions internally as to which system will be considered the source of truth for a particular call it group of data or set of data entities that have to be managed. And then from an integration perspective, and this is back in largely in the information technology department, is they will need to start looking at how do they rearrange the systems to use the information from the source of truth as opposed to relying just on their own thing. And that actually requires a lot of business process reengineering. It needs to deal with how you actually get the data, how you do the triangulation that Dr. Friedrich referred to, and those sort of issues so that you can actually participate meaningfully in, call it, the broader picture that my two colleagues have described a little bit earlier, which is now sharing with other parties.
Thank you very much, Jim, for that addition. I'll read Celestin's question before I read Carl's question. Carl's question is a follow-up to Célestin's question, and Célestin asks, at the Electricity Regulatory Authority of Burkina Faso, we're considering developing a centralized regulatory database that will receive data from electricity operators such as the National Utility, independent power producers, rural electrification entities, and electricity cooperatives. Based on international experience, what key design principles and governance mechanisms would you recommend to ensure the system is sustainable, interoperable, secure, and useful for evidence-based regulation? Thank you. So Célestin is asking a question for the Electricity Regulatory Authority of Burkina Faso. Professor Aspor, if you could share, based on your experience, what key design principles and mechanisms you would recommend for the regulatory authority of Burkina Faso. Yeah.
I think maybe Dr. Otieno is well positioned to respond to that, because finally, when Dr. Otieno is successful with his system, we just copy and paste that system and apply it to other regulators in other countries. So maybe you can do like, what are they doing at EPRA, and then that is how we want to extrapolate to others.
Yes, please, Dr. Frederick.
So for us, we have got a governance framework in place, which we have developed over time, and this one allows for compatible reporting systems. It allowed for shared reliability standards, and then what we call common operational data. So this one is doable. And these things we have even extended to we are extending even now to even consumers. For instance, I talked about IoT, Internet of Things. We have got smart meters, which are embedded by IoTs. And these smart meters is able to communicate instantly, give you information about the load, the required load, about the consumption, about the number of households that are using power. And even it also prevents things like theft of meter. It used to happen in Kenya so much until we came up with smart meters. So you cannot actually even move a meter away because they are GPS enabled. So when they are installed here, if you move it away around even 100 meters, it stops working. So the issue is to go technology way and have got a governance framework in place, a strong governance framework in place that will allow systematic and harmonized way of doing things, so that you have got a common platform that you can use for receiving information. So it is doable. It is doable. We have it in IPRA, and we are using it.
Maybe Dr. Otieno, you can also mention, how is this system reinforced by law? You know, if you just beg for data from these authorities, they may not give you. But how is it reinforced by law?
Yes. No, we have got for us, we have got an advantage in that we have got the framework that covers, we have got energy and petroleum is combined into one. We have got utilities, energy and petroleum, and we have got a governance framework that combines petroleum aspects and even energy aspects. So the issue to do with petroleum and even issues to do with the LPG, issues to do with electricity. And we, as a regulator, we have made it a licensing condition for all entities, because as a regulator, we have got various entities that we regulate. Very, very key entities in Kenya. Number one, we have got the Kenya Power and Lighting Company, KPLC. Number two, we have got KETRACO, Kenya Transmission Company Limited. We have got KenGen, Kenya Electricity Generating Company. We have got GDC, Geothermal Development Corporation. We have got NUPEA, Nuclear Energy Authority. So for us to license them, and even our licensees, we ensure that they are able to provide this data for us. It is a licensing condition. So it is just come up with a law that will compel all these players to submit the required data for you, so that as a regulator, you are supposed to make decisions. You cannot make decisions minus data. Data is very important for decision making. So make it a licensing condition if you are a regulator. Make it a licensing condition. At the higher level, you can invoke the parent ministry, so that it is passed in the cabinet sitting. so that there's a regulations that compels them to provide this information for them to operate in your ecosystem. So it's a condition that is there for us. Yes.
That's very useful. Thank you very much, Dr. Frederick. And based on building on Celestin's question, we are touching on the issue of capacity building. I have two questions around that topic. And Carl is asking, building on Celestin's question about centralized regulatory databases, once such a system exists, the harder challenge is often keeping it fed with quality data and staffed with people who can use it, especially through turnover. What have panelists seen work to sustain the human capacity around this system and not just the technology? And after that, I'll read the other question on capacity building, just so that we can have in mind what we're dealing with. We have a question from, where is it? Sorry. We have a question from Carl, actually. Maybe I'm reading the same question, but go ahead with this one and then I'll read the second one after. Thank you. Dr. Frederick, around capacity building, yeah.
Yes, actually, you see, the human error is enormous, and that is why we actually stress much on using technology. Imagine, like in IPRA, I'm in charge of consumer protection. Each day, I receive around over 1,000 complaints. If I was to sit down and analyze this complaint in person, it would really take me a long time, even a week. The risk of human error, sometimes I become tired and then I make an error. I pass an electricity complaint as a petroleum complaint. So I would really encourage institutions, regulators, to invest on technology. It will really help you a lot because human error is inherent. But for the machine, with the technology, you are able to analyze even information. Data is transmitted automatically. What we do here, like for instance, when we receive petroleum products, because the petroleum products that serves landlocked countries around Kenya are received from the port of Mombasa, which is our port. And this petroleum product goes all the way to Uganda, which is landlocked, to Rwanda, to South Sudan, to Burundi. And we have got a system, an automated system, whereby when petroleum is received, the batch is received, we get it in the system, and we know how much has been received. When they are discharged, we know how much is discharged, and this goes down even to the petrol stations, so that we are able to monitor the petroleum product movement. And I told you this is a licensing condition. If any petrol station or an OMC doesn't do this, we cancel the license, and that is the end. So imagine if you are not getting this data, we will not be able to do planning, to know how much stock we have, for how many days can this particular stock sustain us. And this one is also susceptible to hoarding, because before this, most petroleum dealers and petrol stations used to hoard their products when they know that the price is likely to rise the following month, because they could actually tell, going by the global trends. So some used to hoard their products. So we made it mandatory. So that is instant. When they fuel up a truck, we know how much has been discharged and how much they are remaining with. We know their stock level. So the issue is just about technology. If you leave this thing to human, then you will lag behind, because I'm talking about over 1,000 complaints per day. If we were to do them, we will only be addressing, maybe per year, we'll only be addressing around 10% or even 5% of the complaint. So the systems, technology helps us a lot, because complaints come in, they analyze, and then assign various officers. And even some that do not miss threshold, they return them back automatically to the complainant. So I would just urge that we use technology. And even with technology, we also need audits. So what we do in EPRA, we only now do audit to the system, which is much easier. So technology does much of the work, and then we just do audit every week to ensure that everything is okay. Even with technology, there could be some percentage of error, margin of error. But now we do that by doing audit. But that is what I would say.
Yeah.
Maybe Dr. Otieno, there is one thing around the question that was asked, like how to sustain that system. For example, maybe a data hub, a database, something is developed. How can we continue? Because for the first time, it may be established. You have well-established information. How to sustain it? Maybe you can answer along the job description of someone in IT department or wherever, someone who is sustaining the system, like without fatigue. Around that, please.
Yes, I know there's a whole issue about costs that goes with having these technologies.
Mm-hmm.
And what I would say that it should be incremental. You see, you cannot just start and then you get a whole system that does the whole job. So it should be incremental. As you begin, of course, some you could leave to a human to do. Then as you continue, as you progress the system, of course, you do the audit. You after a periodic, there's a periodic survey, there's a periodic audit of the system, periodic evaluation of the system. And then from there, you are able to improve the system. So it is something that goes incrementally. It is not just a one-off thing. So along the way, you improve the system, you change what works, you improve what doesn't work, and that is it, a whole system. So I think that's what I can answer about that. Yes, it is incremental.
I think you answered part of the question I wanted to ask, Carl's question around affordability. So Carl is saying that the recurring challenge is affordability. Many utilities view data systems and the training needed to master them as expensive, and they're very unwilling to invest even when the operational case is clear. So they wanted, from your experience, what is driving the real cost of these systems? What practical levers exist to make both the technology and the associated capacity building more affordable and easier to justify? I don't know if you want to add more to your answer, and also Jim.
Yes, Daniela. I think I know these systems are expensive. So what you do is collaboration. Like for us, we have got a system that we have collaborated with all our licensees, the players. We have got KenGen, we have got Kenya Power Lightning Company. So the whole thing is about collaboration. You do collaboration in terms of system, because these systems are expensive and are difficult to maintain. And through collaboration, you are also able to tap various talents. So you do it as a group, you collaborate, cross collaboration among various departments, among various ministries. Yes, that is what you do. You do collaboration. There are things that you cannot do alone. So there must be that collaboration and also joint training so that you move together. Because when you train again in silos, you take people from a various ministry and you leave people from the other ministry, and you see this information, they work together. So these people, you should be able to train them together, collaboration in training, and then collaboration in infrastructure. You pool your resources and come up with an infrastructure that will be able to help you all together.
Thank you, Dr. Frederick. Jim, would you want to add more to this question?
Yeah, I think the complexity of this issue is that you need actually a number of different skills to maintain a system. So if you think about building a system, we need, in a sense, it's people that speak more in the language of data science in terms of what the data should look like, and they're involved in how the data is going to be processed and that side of things, almost in a sense more of the developmental hat on. Then the system is built, it's tested, etc. The data scientists, unless they've got another problem to solve, they will move on. Then you're left to people who have operational responsibility. And again, you have people who manage servers, people who manage networks, various other things. Now, if the system is deployed in amongst other systems that share a common network, then at least at the infrastructure level behind the system, you've got some shared services that can be done, or you might have a hosting provider that might look after it. Then you could outsource some of those things. So I think the issue is you need to look carefully at what do I need as permanent staff, understanding that there are people who, in a sense, won't get bored and leave. They enjoy, for instance, keeping their focus in life is they go home at night saying, I kept the system up to date, and they feel happy. But for a data scientist, that's not an appealing prospect. They want a new problem, it's a different personality type, and it's a different set of skills. They will want to work on a problem, solve it, and then move on to the next problem. So unless we are retaining those data scientists with new problems and new challenges and making it an interesting career, you'll find that they'll tend to move on. So if that's once the system is set up and now we're just going to manage it and keep it operational because it meets our current needs, then you might want to say, well, fine, we contract people in to do it. Or what we could do is we could partner, for instance, with universities that specialize in data science, and we could bring researchers alongside that for research projects to do that. And then we could draw on a variety of other skills that, for instance, don't necessarily cost us so much because it might be part of the academic life cycle of those students in terms of, master's or doctorate type dissertation and research work. That could supplement some of those things. So I think we've got to understand the different, call it skills, needs, knowledge, and abilities, the good old SKA matrix, as we call it, skills, knowledge, and ability, for each of the different dimensions that are required to support a system, and then basically say who's permanent, who do we bring on a per project basis, what do we do out of collaboration, and build a model from that perspective instead of just looking at working from the assumption I have to employ everybody on a full-time basis, and I might not be able to retain them and afford the cost as well.
Thank you, Jim. We have a question in two parts by Job. And Job is asking, while IoT is relevant to the future of our energy systems and the regulation, there are two frontiers. One, the hardware requirements from smart metering to ICT hardware and infrastructure, and consider the hundreds of thousands of customers whose meters ought to be replaced with smart meters. The question is, how is this incentivized by the regulator and policies? And then I'll let Dr. Frederick and Professor Ascor answer this one. And then the second question would be for you, Jim, around data transmitted from the IoT structure to ensure reliable and meaningful data is shared, and who pays for the cost of data transferred via GSM or other technologies. So it's a long question, but let's start with the first one. How is the change, the replacement of these meters being incentivized by the regulator and policies? So Dr. Frederick.
Of course, I know it is really a big work to do, and it needs a lot of funds and information. In Kenya, we are doing it incrementally. We are doing it in phases. It's not a one-off thing. But you see that the dividend will be paying, because now the problem that we used to deal with, issue to do with the secrecy in billing. Right now, with smart meters, actually, there's issue about accountability, there's issue about transparency, and even it brings about consumer confidence, because actually with smart meters, you are able to interact with the smart meter and know how much you are consuming at what level. Every minute, you are able to monitor your consumption. And so it brings about the issue of accuracy, issues with the accountability. And with that, we are now receiving less complaints, because for areas that smart meters, the older meters have been replaced with smart meters, we are not getting complaints, because now the consumers are able now to actually interact with how much they consume. They are able to actually monitor their consumption within themselves. So it's something that is really worth. I know it is expensive, but with us, we are doing it incrementally. And again, we have partnered with the World Bank. In fact, around over 50% of the cost of this particular program is being funded by a World Bank and other development partners. In Kenya, we have got something called the last mile connectivity, because we are projecting to connect all households in Kenya by the year 2030. We'll have got 100% connectivity. And we have got development partners have come and are to our rescue, because we know the cost of connecting power, of applying and getting power connected to the household is very expensive. So they have zero rated this, they are paying all the costs. So most rural areas, almost 80% of rural households are being connected to the grid. This is being sponsored by our development partners like the World Bank. So for us, we are getting at least support from the development partners like World Bank, which I'm really grateful. It is seeing us picking up easily. And people are embracing smart meters, because I told you the issue of theft It's no longer there.
Yeah.
It's a meter that you cannot even move. 100 meters, it goes off. It is actually configured to the GPS. So you take the coordinates of a particular area. When you install it here, it cannot be stolen. And even if it is stolen, you can actually trace it. Even if it is taken kilometers away, even to South Africa, for instance, it is taken to Ghana, we can actually trace it. We can actually go up to where the meter is. So it is really, it has come with a lot of advantages. Again, it is also not the issue of, we used to have a lot of faulty meters. This one is almost faulty proof. We have gotten feedback from consumers. It is really doing well for us. I don't know whether I've answered that question.
I think Job can tell us in the chat if he's satisfied with the answer. So I'll let Jim answer the second part of his question around the software. And he's asking, how is the data transmitted from the IoT structure to ensure reliable and meaningful data is shared? So, and he's also asking, who pays for the cost of data transferred via GSM or other technologies? And are regulators passing regulations that, together with laws, will push utilities to transition to these IoT infrastructure? So it's a heavy one, Jim, but I think you can take it.
Yeah. Well, I think it's a well-known problem in the IoT world in terms of how do you get access to what the sensor is actually creating. If I can just take the smart metering example, because I've seen that's quite topical. A lot of smart meters are actually using protocols that transmit data over the power wires. So if you have your smart meter on the boundary of the premises, it can actually transmit data. And this obviously is a vendor-specific solution, depending on the vendor. They will provide you with an option of usually saying, well, do I connect this to a stable GSM network, for instance, if there is one in the area? Or alternatively, do I transmit data through to a node, let's call it the medium low voltage transformer, which would be the final point of distribution for power to a number of properties, say, for instance, on a street or a couple of streets. And they could have a concentrator there, and then they could have a link from there that could be radio or fiber, or alternatively, they could then do further transmission of the data protocol over the medium voltage line up to the high voltage, medium voltage step down transformer that feeds a particular area, and then they could pick it up there. The second thing is, how is the data actually managed? Now, one strategy is to keep the data locally on the meter and then poll the meter from time to time to get a meter reading, which is one way. So the data traffic there is not, in a sense, real time. It's a request and respond type protocol. So the central billing system, for instance, would poll the meter and pick it up or pass an instruction to a meter. If you've got time of service billing, for instance, from that perspective. So there are different ways to handle this. Some networks actually put up in a sense, a kind of a wireless area network using something like the Zigbee protocol or something from that area. And then from that, call it the hub for that particular network, they might then use connectivity from there. So there's many different ways to handle this. It doesn't mean that necessarily you have to have a meter that every time a kilowatt is consumed, it sends a token back to the concentrator to say, oh, this user has just used another kilowatt or whatever unit that or increments of measurement that the smart meter is actually reporting for its billing. So there's different ways. So it's a little bit of what we call a systems engineering question that needs to be resolved. And you would look at what you have available. Ultimately, there's a point where all these different call it consolidated meter readings have to come to the billing system. And that's normally at the distribution level. The distribution operator, maybe the national operator, but whatever, at distribution level, they will aggregate and then they will create the data package that would ultimately put into the billing system to drive the invoicing. And if it's electronic billing, whatever the case may be, from there, set of interfaces. From a regulator perspective, what data you want to access will determine where you want to tap into that flow of information. So the types of, call it transport costs or communication costs that you'd be looking at incurring would obviously be connected from where you're picking up the data from to where you're delivering the data to. You know, it might be a cloud server, it might be your own on-premises type of arrangement, and there you would look at it. Now, the most common way people collect data these days is to use a common internet connection. But what they do is they encrypt the data over the internet connection to ensure that privacy is maintained, or the security aspects of the data is actually maintained. So then it becomes a cost of an internet connection. And the size of that connection is really determined by how much data you want to move in any unit of time. So you could go from there. And then depending on how critical it is, you may want to have certain forms of redundancy or failover in case that link goes down for some reason. If you're using fiber, for instance, and some municipality decides to do road works and forgets that there's a fiber there, and they put the TLB through the fiber, which I've experienced in my role as an IT director and CIO of one of the large ISPs in South Africa, then you understand that spatial diversity is actually quite important to protect your redundancy for your high capacity link. So that's really a risk and business case decision in terms of the criticality of the data. It has to be delivered to a particular point.
Thank you
So I'm
very
afraid it's
much.
not really quite a simple answer. It's a little bit more of a systems engineering.
It's not, but
and you cost your alternatives, and you look at what's an appropriate way to do it.
All right. Thank you very much. I think the last question I'll read from the chat is for Professor Asquar and Dr. Frederick. We have a question from Sarah, and Sarah is saying, reliable data often exposes systemic inefficiencies or political choices in tariff structuring. How can regulators insulate data collection and reporting from political interference to ensure it remains a neutral single source of truth for investors and consumers? So, Professor Asquar.
Before we get a testimony, we want a testimony from EPRA. So what area is doing now is to remove those skepticism and fear and what among our regulators. How do we do? Is during the capacity building, during the training, during those meetings, we try to share those information from various regulators. Like, well, we shared and it's still okay. And this is how we involve our politicians. These are sensitive issues. Sometimes it ends up being fired, So let Dr. Otieno respond, but that is the case study we are taking from our members. Yeah, please.
So I want to say that consumer trust is very key in digital transformation. Therefore, the way we deal with data should be authentic. It is a manner that is governed by the law. So in Kenya, for instance, I've said we have got a law protecting how we acquire, how we store, how we process, and how we consume data. We have got the Data Protection Act of 2019. So this act, together with the constitution, you see in Kenya, we have got a very progressive constitution, which was promulgated in 2010. So we also have got various independent bodies. So this one actually regulates and also protects any form of interference from any quarter. So we are very safe in Kenya. We don't get any interference from any politician from anywhere, because we have got proactive laws that actually prevent this from occurring. In dealing with the data, I think we really need to put in a system and processes that can actually maintain consumer confidence. So when we are dealing with data, for instance, in IPRA, I've said that our data are categorized. We have got open, we have got confidential, and we have got restricted data. So when dealing with data, sometimes you can explore various options that you have. For instance, you can obtain informed consent. For instance, if data is required from a given utility or a given player, a licensee, and this information is required for the public use, maybe even a parliamentary committee wants this particular data, we can seek informed consent from that particular utility, from a particular player. What we can also do, another option that's available for us in EPRA, is the issue of anonymization. I think Professor talked about it, data anonymization. We have used that before to provide this particular information, data to the public when it is needed, because sometimes data is needed for the public good and even for the government and even other players to make informed decision. We also do what we call encryption of data. So we encrypt certain sections that might reveal sensitive information. For instance, in consumer protection, we normally publish determinations because we get disputes and even complaints. Sometimes we bring the complainant, which is the consumer, and the utility provider. For instance, the Kenya Power. We bring them together and then we listen to them. They submit their evidence. Then we call them for a hearing. Then we make a ruling. And you see the ruling that we make be as equal weight as that one made by the court of law. So these rulings normally make precedents. And as EPRA, we normally publish them in our website. So before we publish, we normally ensure that we do what we called redaction. So by redaction, sometimes we hide sensitive information. Like for instance, if it was a complaint about metering, we hide the meter number because somebody can actually take the meter number and then match it with a particular individual. We also remove items like names. So we do what we call redaction. So these are some of the measures that we normally use in IPRA to process personal and sensitive information. So at every stage, we normally determine whether this is the data required. Are they confidential? Are they restricted? Or are they open data? So we categorize them into three. So we only give out what is necessary according to the levels that are required. Thank you.
Thank you, Dr. Frederick. And one last question. As we are a capacity building institution at the African School of Regulation, it would be interesting to hear from all of your perspectives on what training regulators on the call or people really interested in data for the energy sector need. So what trainings would you recommend? So I'd start maybe with Jim, Dr. Frederick, and then Professor Asquar.
That's a very good question. I must say, having been through one of the courses with ASR, which I thoroughly enjoyed and was high quality, I found very useful. I think my exposure in the regulatory space really has been the strong emphasis on, call it the economic aspects of regulation, and that side, which really is what the bread and butter of regulation is all about at the end of the day. I think the area that we're still exploring, and I know from ARFU's side, I'm busy running a project with the member regulators, looking at the issue of what regulatory interventions do we need to consider as we approach the whole issue of resilience of our utilities. Because as we're seeing, as the world's emerging into asymmetric warfare, utilities being threatened sometimes to achieve political ends or that type of thing, it's putting a new emphasis on that as a requirement. But as regulators traditionally have been much more focused on the issues of economics and legal issues, etc., this in a sense is a little bit of a mindset shift. So I'm currently working across the 5 African regions with the regulators to develop that. Very privileged to have Dr. Tino on our steering committee. If you've forgotten, you are part of us, Frederick. As we are looking to devise what would be an appropriate curriculum to, in a sense, expand the understanding of the regulator. And of course, the challenge here is the regulator is not the operator. And we want to create appropriate regulation here that, in a sense, sets the guardrails in terms of practices we'd expect to see from the utilities, but we don't want to delve into actually prescribing how they should run their utility. So it is very much focused on ensuring certain outcomes as opposed to using regulation to promote certain solutions or approaches. So that's an area that, as I say, that we're exploring currently. And I think as we get a better understanding of that and the role of ASR in that, I think will become clearer in that process.
All right, thank you very much, Jim. And Dr. Frederick, what training would you recommend to the regulators on the call, especially with regards to data systems and technology?
Yes, yeah. I understand that for a long time, most regulators, like EPRA in Kenya, for instance, for a long time, they've relied on lawyers, they've relied on engineers, and then economists. That is the bulk. But given the rapid change in technology, even the lawyers, even the engineers, even the economists are now moving towards AI, the use of AI, because AI is doing marvelous work. It is really saving time, promoting accuracy in the information that we have. Of course, the human interventions is minimal. Sometimes it's very much minimal. So for us, the training that I'm seeing in the landscape, especially in Kenya and East Africa, is the training to do with the AI use. I've also seen things to do with cybersecurity. It's also common. We have got digital risk management. I've seen many people applying for that. Data mining is also an area that I've seen many people opting for. And then regulatory technology, RegTech, is also an area that I've seen most of the staff really eyeing for. So those are the areas that actually you can leverage on.
All right. I'm sure people on the call are taking notes. And to end, Professor Asquar, 1 or 2 trainings for our listeners.
I think Dr. Otieno and Jim have already covered those topics, and I just overemphasize now the use of AI, because you can rebrand every kind of training that was going on and enhance it with AI. That's actually what we are doing at AREA, and it's an eye opener to many. Now, and based on this today's webinar, we have realized that case studies will help a lot, like the case studies that are coming from EPRA, research-based findings, and so on. So this could be an eye-opener to most of the regulators. So come up with the real success stories, real case studies, AI use, and big data analysis, cybersecurity, as you have said, but with the real case studies. That is what the emphasis of the African School of Regulation should put onto. Yes. Congratulations for the great job you are doing.
Thank you very much, Professor Asquar. And to end, I'd like to give our panelists an opportunity to give us a message in 30 seconds, what you would want the participants to leave the call with. So a short 30 seconds message. I'll start with Dr. Frederick.
So thank you very much, Daniela. For me, I just want to tell everybody, I want to thank them for attending this particular session. And I want to say that technology is here with us, and we cannot run away from it. It is really making a lot of tremendous transformation in the way in which we do things. Therefore, we must just adapt it if we want to keep the pace. Because most of the people we regulate, the licensees and the common citizens, need services that are fast, effective, and efficient. And this one can only be achieved when we embrace technology, because technology is helping us do a lot. And I want to say that most of these technologies, we know they are expensive. I want to urge institutions not to rush. I've said there's the issue of about incrementalism. You can face the technology so that you start small and then you increase gradually. It's not a one-off thing. You just start small, you evaluate, and then from there, you take the next step. So I want also to urge Africa as a continent, the issue of collaboration. Whenever collaboration and cooperation is something that we really need to go that way, because it's the best way to ensure that we can harmonize our systems. You see, disjointed system will bring a disjointed regulatory landscape, which is not good for us. That one will even discourage cross-border sharing of information, will even discourage investors. So we need to have got a common platform, a common digital platform from which we can all act on, from which we can all borrow from, and from which we can conduct our regulatory work. So cooperation is really needed. I was talking about the other time when we were going to, I saw so many people like moving from maybe from Kenya to South Africa. Like last time you had got a full conference in Namibia. Most people had got to travel all around 20 hours just traveling, so many visas, people are restricted. And I was comparing, when you go to Schengen area, you go to Switzerland, you can move to France, you can move to Germany, you can move to Austria, you can move to Italy. It is seamless. It is like we're in the same country. Yes, it is. Nobody asks you for your passport. Nobody. You just move. You can never know even that you are entering France. You are now in Italy. It is seamless. That is what I want us to adopt in Africa. Regional cooperation. At least with utilities, we can cooperate because we have seen many utilities cut across the borders. For instance, in Kenya, we get electricity from Uganda. We get electricity from Ethiopia. And the same with other utilities like water are shared across the boundaries. The Nile, all the way from Uganda to Egypt. We have got things like transport. They cut across the countries. Why don't we come together as nations and then we cooperate so that we have got a shared platform, so that we have got common data system, common regulatory landscape, or common laws that will govern our operations. Thank you very much.
Thank you very much, Dr. Otieno. Very important message you're putting out there. Jim.
All I can say is a big amen to Dr. Frederick. I absolutely support and agree with what he stated. Maybe just one thing to add is our participation in terms of data information is going to do one thing. It's going to expose the state of our own data and our back office. So every regulator should make it a priority to sort out their master data, get their house in order in that sense. And the second thing to bear in mind, as we integrate, we become part of a shared cyber risk. So what happens is any party that's vulnerable from a security perspective offers an open door to propagate a security risk to the other participants through that connectivity. So we, in a sense, are going to end up having to manage a shared threat surface, as we term it in the industry. So together with data quality, how we process it, and the fact that we realize that we are all now contributing to the security landscape of the data sharing platform that we are envisaging in the future, we all have a responsibility to ensure that we've done the necessary essentials within our own areas of responsibility for that.
Thank you very much, Jim. Very important message as well. And to end, Professor Asquar.
Is available to the
You're breaking a little bit, Professor Asquar.
Oh,
okay.
Can you hear me now?
Yes,
okay.
We can hear you now.
Resource that your institution, that's why you're going human resources. So
we cannot hear you.
Build your advanced, utilize the resources available, like from the institutions like ASR and a rare asset. So let us build our capacity, build our institutions. The resources are here with us. Let us utilize them.
Thank you very much, Professor Asquar. We were able to hear the last part of your message, and we thank you for that. Just before I let Executive Secretary of AFOR, Debbie Rhodes, give closing remarks, I'd like to thank our panelists, distinguished panelists, for their time and for imparting us with very, very important knowledge on this call. I personally learned a lot, and I'm very sure our participants did as well. And we hope to have you in, if not consecutive sessions we'll be having at the ASR, but also collaborate on other initiatives. Thank you very much for your time, Dr. Frederick, Jim, Professor Asquar. Thank you very much. Debbie, would you be able to give us closing remarks?
There you go. Thanks. Can you hear me?
Yes, perfectly.
Yes.
Thank you. So good afternoon, everyone. It's a great privilege for me to close this webinar, as Daniela and she's also thanked everyone on my list, but just to thank everyone again, including the participants and African School of Regulation for collaborating with AFU in bringing this very important topic to our members. And as Daniela said, I also learned a great deal from today's webinar. Secondly, to our esteemed panelists, Jim, Dr. Frederick, Professor Asqua. One of the outcomes of the 22nd AFU annual conference earlier this year was the urgent need for regulators to harness emerging technologies, including AI, big data, and smart metering, to build more inclusive, resilient, and investment-ready regulatory environments. So the panelists this afternoon addressed many of these areas and unpacked some of the challenges of data storage, cybersecurity, and privacy protection. And I think I want to also just highlight and thank the participants, who engaged with throughout the session. And I think very thought-provoking questions. And it seems to me that there needs to be a follow-up on this webinar, because I don't think we've unpacked everything. And I think that there's certainly left quite a few questions to be answered. But Daniela, and thirdly, I'd like to thank you who moderated the session so effectively. So thank you again for all the participants, the panelists, and our esteemed moderator, and the African School of Regulation. We look forward to the next webinar. Thank you, Daniela.
Thank you very much, Debbie. Thank you very much again to our panelists and participants, and have a great end of day. Thank you.
Thank
bye.
you. Bye-bye.
Bye-bye. Thank you very much.
Thank you,
Bye-bye.
Professor
Thank you,
Asqua.
colleagues. Bye-bye.